Hello guys, this is Arvind here from Edureka and I welcome you all to this session on Maven tutorial. So before we move any further, let us have a quick look at the agenda for today's session. We will begin our discussion with the topic, why at all do we need Maven? Then we will talk about what exactly is Maven, the Maven architecture, and few of the other key terms related to Maven. Then we will also discuss the various advantages that Maven has to offer. And finally, we will have a look at the demo of Maven, wherein we will build a project using the Maven. I hope I'm clear with the agenda, guys. So let's not waste any time and straight away start with our first topic. Why do we need Maven? Okay, so new programmers, especially Java programmers, they have this question like, why do we need Maven for building project when we have Eclipse? So what Eclipse is? It is nothing but an IDE. IDE stands for Integrated Development Environment. Eclipse provides an environment for developing your project. That's it. It doesn't build your code, but Maven is used for building the code. And there's one more thing that I would like to tell you that suppose you're working on a project and most of the Java projects, they require you to work with third-party libraries. For example, if you're working on a Spring MVC project, there are numerous dependencies that you need for these projects. Dependencies are nothing but the libraries or the jar files. So for Spring, there are 10 to 12 libraries that you need. So to use these libraries, you first need to download them and then you need to add those to your project. This is a tedious task because all of this needs to be done manually. There's one more problem here. Suppose you're working on Java 8 version and for some reason you need to upgrade your project from Java 8 to Java 9. In this case, you again need to download and add these dependencies for the latest software version. So this is not at all a good practice where you have to do things manually. So this is where Maven makes your life easier. Maven can solve all your problems related to dependencies. You just need to specify the dependencies that you want in a pom.xml file of Maven and Maven will take care of the rest. So even in the later stages of the project, you need to upgrade the version of the software that you're using. Maven will handle all such issues elegantly. For example, like even if there's a change in the version of the software, you need to make the change in the pom.xml file of Maven. And that's it. Maven will automatically download it for you. This is the reason why we need Maven. So before Maven, we had this build tool called Ant. The problem with Ant was we had to write very long scripts for executing our tasks. For example, you have to define what your tasks are and when you need to execute those tasks. So this was a problem with Ant. Then came the Maven framework, and Maven is widely used in the software industry as of now. So now since we know why do we need Maven, let us have a look at what Maven is. Maven is a powerful build automation tool that is primarily used for Java-based projects. Maven addresses two critical aspects of building software. First, it describes how software is built, and second, it describes the dependencies. It uses conventions for build procedure and only exceptions need to be written down. An XML file describes the software project that is being built, its dependencies on the other external modules and components, the build order, the directories, and the required plugins. It comes with predefined targets for performing certain well-defined tasks such as compilation of code and its packaging. Maven dynamically downloads Java libraries and Maven plugins from one or more repositories such as the Maven Central Repository and stores them in the local cache. This local cache of downloaded artifacts can also be updated with the artifacts created by the local projects. Public repositories can also be updated. Maven can also be used to build and manage projects written in C#, Ruby, Scala, and so on. The Maven project is hosted by the Apache Software Foundation, where it was formerly part of the Jakarta project. So this is Maven in a nutshell. So now let us discuss the Maven architecture. As you can see in this diagram, these are the various components of Maven architecture. This is the local repository or the local machine that you work on. This is the central repository and this is the remote repository or the remote web server. So whenever you specify any dependency in the pom.xml file of Maven, Maven will look for that file in the central repository, this place. Okay, if the dependency is present in the central repository, Maven will copy that dependency onto your local machine. But if it is not present here, Maven will fetch it from the remote web server or the remote repository using internet. So internet is very much mandatory for using Maven. This is how Maven architecture or Maven works. Now let us talk about the Maven lifecycle. The Maven build follows a life cycle to deploy and distribute the target project. There are three built-in life cycles, that is default, clean, and site. The default is the main life cycle as it is responsible for the project deployment. The clean life cycle is used to clean the project and remove all the files by the previous build. And site is used to create the project's site documentation. Each life cycle consists of a sequence of phases. The default build life cycle consists of 23 phases as it is the main build life cycle of Maven. On the other hand, the clean life cycle consists of 3 phases and the site life cycle is made up of 4 phases. So since we now know what Maven lifecycle is, now let us deep dive into what Maven phases are. A Maven phase represents a stage in the Maven build lifecycle. Each phase is responsible for a specific task. Here are some of the most important phases in the default build lifecycle. Validate. This phase checks if all the information necessary for the build is available. The compile phase compiles the source code of the project, whereas the test compile compiles the test source code. The test phase is responsible for running the unit tests of the application. The package phase is responsible for packaging the compiled source code into a distributable format, that is the WAR format or the jar format. Integration test is the phase in which process and deployment of the package is needed to run the integration test. In the install phase, you install the package to a local repository, and in the deploy phase, you copy the package to the remote repository. So these were a few important phases of the default build lifecycle. Phases are executed in a specific order. This means that if we run a specific phase using the command such as maven test, so all the preceding phases before maven test will also be executed. For example, if we run the deploy phase, which is the last phase in the default build lifecycle, that will execute all the phases before the deploy phase as well, which is the entire default lifecycle. So now let us talk about the Maven goals. Each phase is a sequence of goals and each goal is responsible for a specific task. When we run a phase, all goals bound to this phase are executed in order. Now let us have a look at some of the phases and default goals bound to them. As you can see in this diagram, this is the format of specifying the goals. The compiler is a plugin and compile is a phase. The compile goal from the compiler plugin is bound to the compile phase. The compiler test compile is bound to the test compile phase. Surefire test is bound to the test phase. jar::jar is bound to the package phase. So this was all about the Maven goals. Now let us talk about Maven plugins. A Maven plugin is a group of goals. All execution in Maven is done by plugins. A plugin is mapped to a goal and executed as a part of it. A phase is mapped to multiple goals, and these goals are executed by a plugin. We can directly invoke a specific goal while Maven execution. A plugin configuration can be modified using the plugin declaration. For example, compiler plugin compiles the Java source code. As you can see in this diagram, the compiler plugin has two goals, namely the compile and the test compile. We will get to know more about the plugins in the demo that we will execute in some time. Moving on, we will now discuss the various advantages that Maven has to offer. Maven's primary goal is to allow a developer to comprehend the complete state of a development effort in the shortest period of time. While using Maven doesn't eliminate the need to know about the underlying mechanisms, Maven does provide a lot of shieldings from the details. Maven allows a project to build using its project object model, that is the POM, and a set of plugins that are shared by all projects using Maven, providing a uniform build system. Once you familiarize yourself with how Maven project builds, you automatically know how all Maven projects build, saving you immense amounts of time when you try to navigate among many projects. Maven provides plenty of useful information that is in part taken from your POM and in part generated from your project's sources. For example, Maven can provide change log document created directly from source control, cross-reference sources, list of mailing lists managed by the project, the dependency list, and the unit test reports, which includes the coverage. As Maven improves, the information set provided will improve, all of which will be transparent to the users of Maven. Other products can also provide Maven plugins to allow their set of information alongside some of the standard information given by Maven, all still based on the POM file. Maven aims to gather current principles for best development practices, and it makes easy to guide a project in that direction. Maven also aims to assist project workflow such as the release and the issue management. Maven also suggests some guidelines on how to lay out your project's directory structure. Once you learn the layout, you can easily navigate any other project that uses Maven and the defaults. Maven provides an easy way for Maven clients to update their installation so that they can take advantage of any changes that has been made to the Maven itself. Installation of new or updated plugins from third parties or Maven itself has been made trivial for this reason. So these were a few advantages of Maven. So guys, now let us have a look at the demo project which we will build using Maven. For this project, you need a few things pre-installed on your system, like you need Java, you need Maven, and also you need an IDE, most preferably Eclipse on your system. So I've already downloaded and installed these things on my system. And here, as you can see, this is the Eclipse IDE. And here I've created a project. Okay. So I'll show you how to create a project in Eclipse, specifically Maven project. Okay. So here you click on File, New, Maven project. So here you check this box, like create a simple project, skip archetype selection. Archetype is nothing but a template which is provided by Maven for building projects. Okay. So as of now, you can create a simple project, click on next. Okay. So here are a few things that we need to talk about. The group ID. The group ID is nothing but the unique identifier that owns the project. Here you can specify anything like com.edureka, for example, in my case. So now coming back to the artifact, this will be the final name of the compilation unit of your project. So you can specify, like, since my code is written in Selenium, like I've written a Selenium code along with test.ng. So I will write something like maven.selenium.test.ng. Okay. Version indicates the version of the created artifacts. Like if your project deals with the multiple versions, then this is a very useful parameter to deal with such versions. The default packaging is jar, and you can also change it to pom or var. Okay. And here you have to provide the name of the project. Okay. So in my case, let us type dummy project. Okay. Here it says Maven Selenium test.ng already exists. So what we will do is maven.test.ng .selenium. Okay, good to go. Click on finish. Okay, so as soon as you click on finish, this is our project maven.testng.selenium. So if you click here, you will see a hierarchy of folders. So this is the best part of using Maven. So Maven prefers convention over configuration. So now let us talk about these folders: src main Java, src main resources. So this is the place where you write the application code. Like if you're developing a web application, you write that code over here in the src main Java. And all the resources that you need for developing this code are present here in the src main resources. And it is also the responsibility of the developer to write the code for developed application, test the application. So for testing purpose, the code is written here, src test Java, and whatever the resources are that you need for testing the application, those are present in the src test resources folder. So this is the JRE system library, and this is the pom.xml. This is the most important part of Maven project. Okay, so we will come to that part later. One more thing that I would like to tell you that these are the various Java libraries, and the version of Java that you have downloaded must be compatible with this one. Like for example, on my system, I have Java 12. Okay, so here it shows some other versions. As you can see on the screen, yeah, you should click on this one. Workspace default JRE, JDK 12.0.1. Okay, apply and close. Okay, so now let us talk about few of the elements of pom.xml file. This project is the root element of the pom.xml file. The version here specifies the version of the artifact that is created, and snapshot indicates the work is in progress. And the name of the project, as you can see here, is dummy project. Okay, so these were a few elements of the pom.xml file. Right now we have mentioned nothing in the pom.xml file. Okay, so we will add dependencies and plugins here in this pom.xml file. So now let us have a look at the code that I've written. Okay, what this code does is, this is the Selenium script for testing a web application. Basically, I've written a code in which you automatically open a web browser, you navigate to a URL specified, and then you try to fetch the title of the web page that you navigate to, and then you try to match that fetch title with the actual title. I mean, there's a comparison between the expected title and the actual title. If both the things are the same, then the test case is passed, else the test case fails. So this is exactly what I've written in this code. And this code is written in this package. As you can see, in the src test Java, in this package, I've written this code, demo class.java, as you can see here on the screen. Okay, so this is the code. So now we will talk about the various phases. Now we will try to run this script. As you guys must be knowing, Selenium is the main tool for testing web application, but it has limitations such as test case management and report generation. Hence, most number of times we integrate Selenium with TestNG. TestNG generates structured test reports, and TestNG is also useful for performing unit tests. TestNG provides us with test annotations for managing the test cases. So here, since we are using the TestNG framework, we need to convert this Java file into TestNG. So whenever you click this, you will see that there's one more XML file created here called textng.xml. So this file is nothing, but it contains the name of the class that you have created, that is demo class. So that's it. In the pom.xml, we have to specify, since we are using Selenium and TestNG, we have to specify those dependencies in the pom.xml file. Okay, so yeah, as you can see, these are the dependencies, Selenium and TestNG. And how do you get these dependencies? Okay, so simply go to MVN repository. Okay, so simply type here Selenium. Okay, so you can see this Selenium Java. You need to select a stable version of the Selenium. As of now, this is 3.141.59. So you have to click on that. Okay, so here you can see Maven, and you need to copy this dependency thing. Okay, these 5 lines, and you have to paste it in the pom.xml file. Okay, Selenium Java and the version. Okay, so I have to write here the version 3.141.59. I hope it's the same. Yeah, 3.141.59. Okay, so this is the thing that you have got from MVN repository. Also, similarly for TestNG, you have to search for TestNG over here, org.testng. Okay, so click on TestNG, stable version 6.14.3. Click on this, copy these 5 lines of Maven dependency, this thing, and you need to paste it over here. I've already done this, just the version number is different. Okay, so what is the version that is available here? The latest one, 6.14.3. Also, apart from the dependencies, since we are testing the application, you also need two plugins, which is nothing but the compiler plugin. As the name suggests, it is used for compiling the source code, and the surefire plugin, which is used for unit testing. So you also need to add these plugins under the build tag. Okay, as you can see here, this entire thing you need to add here in the pom.xml. And once you add those, you have to simply save it using Control S. That's it. So now it is the headache of Maven to download it for you and use it in your project. Now we will try to run the various phases of Maven. Okay. So to run the various phases as we discussed earlier, for example, if we want to run Maven clean, what Maven clean does is it cleans all the previous project builds that have been created, not by us, maybe by some other user or something else. Okay. So here I will click on Maven clean. So how to reach there? Right click on the project, run as Maven clean, and now you will see the output on the console. Okay, so as you can see here, it shows build success. Also guys, note down a few things that work in the background, like Maven clean plugin. This is the thing that is working in the background for cleaning the project. Okay, since we are testing this application, we will try to run the Maven test. Okay. Since now I'm trying to run the Maven test, since we want to test the web application, this will also execute all the previous lifecycle phases of Maven, which exist before test. So now let us click on Maven test and see what happens. Okay, you can see the browser. Okay, so it shows build success, tests run 1, failure 0, error 0, skip 0. Okay, so we are good to go, guys. This works perfectly. So we have already seen how to execute this test code, and now we have to do the similar thing using command prompt. You can do this even without using an Eclipse IDE. So what we will do is we will get the path of the pom.xml from here. Let's right click on pom.xml file and the location. Okay, so this is the thing that we need to copy. Since now we have copied the path, okay, we have to navigate to that path. We are at the location of the pom.xml file, and now we can run the same commands which we did through Eclipse, such as mvn clean. Press enter. Let us see what it does. It shows build success. Everything is working fine. Now we will test the code using mvn test test. Okay, so let us see what happens. Okay, so it is installing all the libraries that are required for this project. The build is success and test has run successfully. No failures, no errors, nothing. Okay, so this works fine. And this was all about the demo project from my side. I hope you have enjoyed this session as much as I did. And if you have any queries related to this, you can post them in the comment box below. We will try to get back to you as early as possible. Thank you.